We're going to go ahead and get started. Good afternoon, everybody. This talk is about Couchbase full-text search. My name is Marty Schoch. I've been with Couchbase for about 5 years now, and I've worked on a variety of projects. And I'm also joined on stage here with Steve Yen.
Hey, everybody. Good to meet you. I'm one of the co-founders here, so I've been here longer than Marty. But I have been working on full-text search with him, so.
Great. So a quick rundown of our agenda. We're going to start off by asking, why are we building this thing? What is it? How does it work? How does it scale? We're going to do a demo, a live demo, running on my laptop here. We're going to conclude with some best practices and then look to the future. So why are we building a full-text search for Couchbase? Well, one of the things we know for sure is Couchbase users need to search their documents. Couchbase has adapters which connect Couchbase up with things like Elasticsearch, Solr, LucidWorks. And these are the most popular adapters that we have. There's some Spark and Kafka are catching up, but at the moment, the Elasticsearch adapter is the #1 adapter. So we know users are using this. And the dedicated search solutions are great. They're very powerful solutions. You can solve lots of problems with them. But one thing they're not is easy. It means you're going to have to run your own cluster. And that's going to mean not only just the physical resources, but also the staffing, the training, and so on to be an expert enough to run those in production. So we've really approached this from the perspective of, could we build something that's both simple, integrated with Couchbase Server, and really focus on this 80-20 split of features. The adapters that I just mentioned before, they're not going away. We're always going to have users that need that full Elasticsearch cluster, and they're going to be able to do that. But for a lot of our customers, they have a relatively simple search use case. So if we can deliver that 80%, that'll save a lot of our customers from having to run a separate cluster. So what is full-text search? Well, obviously, the thing most people think about first is something like Google. There's this magic box. You can type in some search terms, and you're going to get things that are relevant coming back as a result. If we look at how that would work in full-text in Couchbase, I have a screenshot here. A little bit hard to read on this screen. Apologize for that. But what we're seeing here is a search that's run inside of Couchbase Server in the admin UI. I searched for some terms. And the results you're seeing here, they're showing the doc ID, which is a link back to the document. We have a result text snippet. So just like you would get with Google, there's a little bit of text which helps you understand why is this document a part of the search result. And then going beyond that, again, it's maybe hard to see, but those yellow boxes you're seeing are the search terms that you entered into the system being highlighted. Again, giving you more understanding about why this particular result is being shown to you as a result. Called out some of these things here. So how does this actually work? Well, there's 3 main pieces that are sort of powering the system like this. The first is inverted indexes. The second is a language awareness. The language awareness means being able to control and tell Couchbase this piece of text is in English or French or German. And then ultimately scoring, right? A search result, unlike a nickel query, which might sort of very finely drill down to the results you're interested in, a search result, even for a common search, might return half the documents in your database. So you have to figure out which are the ones you're going to show to the user, even if maybe that's 500,000 documents that match. Which are the 10 out of those 500,000 that you're going to show the user? So let's go through these one at a time. What's the inverted index? Well, I've got a sort of logical picture here of what an inverted index is. The main thing is the key in the index is going to be the terms that are in the document. And then the value is the various documents that use that term. It's fairly straightforward. But it's a different structure than most of the other indexes inside of Couchbase. Now, we also talked about language awareness. How is that actually implemented? Well, I have a simple example here that shows the text analysis process that we use on text. So looking at this first on the left-hand side of the screen, you see we have a document which contains the word beauty. That's going to go through this text analysis pipeline. And one of those phases is what's called stemming. The result of that is that the element that's put into the index is BAUTI. You notice the suffix of the word changed, and also it's all lowercase. Now, why is that important? Well, when at some later time a user comes to run a search, and they happen to search for beauty full, that's going to go through that same text analysis pipeline that the document went through at index time. And the output is ultimately the same, BAUTI in lowercase. So why is it significant that they're both the same? Well, what it means is the piece powering the search behind the scenes is doing an exact match. That's something that's very easy for computers to do. That's important to know that that's going on, right? Because a lot of people assume that the way search works is that there's a bunch of fuzzy comparisons going on at the index level. And while occasionally there are for some searches, the way we make things fast is by making it powered by these exact matches. And finally, we have the topic of scoring. As I mentioned earlier, it's not uncommon for a search to return a large number of results. I ran a search here which has 473 results. It's pretty safe to say no user is going to click through and look at all 473. So how do I prioritize and show the users the most relevant ones? Well, Couchbase FTS implements something called TF-IDF scoring. It's a fairly standard scoring model. You can read more about it if you're interested, but I just wanted to give a little bit of a walkthrough about how it's actually implemented. So the TF portion stands for term frequency, which is to say how often does that term occur in the document. The idea being if you search for a term and this document uses it 10 times versus 100 times, right, the document that uses it 100 times is going to score higher because it occurs more often. IDF, on the other hand, is the inverse document frequency. So this is how many of the documents in the total document population use that term. And the more documents that use it, the lower that's going to affect the score. And the reason is a document, if all of the documents in the population use that term, it's not that interesting a term. It doesn't differentiate one document from another out of the whole population. The next topic we want to look at is something called the index mapping. The index mapping is what allows you to tell Couchbase how you're going to index a particular document. Your documents typically have different kinds of documents inside of one bucket. And then you have maybe 10 or 100 fields inside of your JSON. So we need to be able to communicate how that is going to be handled in the index. And I've identified just a few key categories. We're going to see this more carefully in the demo later. The first thing you commonly want to do is be able to exclude fields or whole subsections of the document. You often have things that are interesting in your document, but not interesting to the search index itself. So you want to be able to just indicate those, push them out of the way. Second is being able to configure the behavior based on the type of document. So again, you often have different types of documents in the same bucket. If you're familiar at all with the beer sample data set that we ship with Couchbase, that contains both beers and breweries. So again, it's not uncommon to say, I'm going to build an index just on the beers or just on the breweries. Or maybe if I do an index both, I want to index them differently. And finally, you want to drill down to the actual fields into the document and say, this field I want to index this particular way. You want to be able to handle nested structures and say, OK, this field is inside some subsection, and I need to account for that. And we also want to be able to handle arrays of fields as well. And finally, I wanted to just touch on a topic of precision versus recall. This is something that is sort of not obvious to people when they first get into full-text search. That mapping I just described, you might be thinking of it as a one-time operation where you build just the perfect mapping and then you walk away from it. But in reality, that's not how it works. What you find is you get something that's good enough, and you start using it. But you find problems with your search. I ran this search for this term, and I didn't get the document back that I expected. And what you're going to do is you're going to have this iteration process where you keep going back to your mapping to make changes. But this is why you need to be mindful of precision versus recall. When you make a change to your mapping and you think you've made an improvement, you may have improved one use case that you're testing right now, but you may actually be making other search results worse at the same time. So always keep in mind this notion of precision versus recall. It's not just what you're matching, but out of all of the ones that are matching, which ones are coming back in the most relevance. At this point, I'm going to hand the stage over to Steve, and he's going to talk a little bit about how Couchbase full-text scales.
Cool. Thank you very much, Marty. That was a lot of good info on well, how full-text search works. Now you might be wondering, well, how does this stuff work when you actually have multiple nodes and you actually need to have this thing scale out in a cluster of Couchbase Server? So you might have a bunch of sub-questions related to this. For example, like, well, do you guys do index partitioning? How is that partitioning done? Is it automated? The answer to that question is check. Yes. Oh, yes, we do that. So it's actually related a little bit to the hash partitioning that we actually have for the vBucket side of things. Some of you might know in Couchbase that when you actually define a Couchbase bucket, it's actually sharded up into multiple shards, 1,024 of them, called vBuckets. And the way your documents actually get into a vBucket is via hash function. So similar to, I guess, California nowadays, we got hash functions or hash, no. All right, thank you for the laugh. All right. All right. There we go. So now when you define a full text search index, there's actually a very simple parameter that says, given these vbuckets, how many of them actually are assigned to a particular index partition? By default, the number is 32, so vbuckets 0 through 31 are assigned to FTS index partition A. Vbuckets 32 through 63 are assigned to index partition B, and so on and so on. Next, you might have the question of, like, now that you actually have these full text index partitions, how are they assigned to multiple nodes? And is this done in an automated way? The answer is check. Oh, yes, it is. So there's auto placement of these index shards, index partitions to the multiple nodes. It's done in a balanced kind of way where we're trying to evenly divide the index partitions across the nodes so that you get an even usage of resources. One thing about this is the full text search feature supports what Couchbase calls multidimensional scaling, so that as you add more nodes to your cluster, you can actually choose, oh yeah, this node should be a data node, this node needs to run data and query, this node needs to run just FTS. You can have like granular choice of like what services you actually want to run on what nodes. So you could have every node running every service, or you could say some nodes are just running the FTS service only. Next question you might have is, well, now you can actually have that going on, do you support rebalance? Is this stuff integrated into the rebalance lifecycle or feature set of Couchbase? And the answer is check. Oh, yes, it is. So you can add nodes, swap rebalance nodes, remove nodes. It's all integrated into the rebalance workflow of Couchbase. What's happening now is, you all probably are familiar with the existing rebalance feature of Couchbase. So when you press the rebalance button, the first phase of what's going to happen is the same old rebalance that you know and love, which is the movement or the reassignment of vbuckets to the brand new nodes and nodes that are remaining in your cluster. That's sort of like the phase 1 of rebalance. Next, in a second phase of rebalance, FTS index partitions are maneuvered around and reassigned to brand new nodes. So it's almost like this two-phase thing. So the first 50% of your rebalance is vbucket movement. The second 50% of your rebalance becomes FTS index partition movement. Now that you actually have these index partitions assigned across multiple nodes, how do queries work? Is querying scatter gather? And the answer is, oh yes, check, it is. One thing about this is you could send a request to any one particular FTS node, and that node is going to scatter and gather that request out to all the index partitions across the cluster, gather the results, score them, sort them, and provide one result back up to the client. You can actually hit any particular FTS node, and it's just going to work fine. And when you use the SDK, it actually automatically knows which nodes are the FTS nodes, and it'll actually do all the work for you. So that's very nice. One aspect of this is partial results are OK, or handled. By that I mean, as we actually do a index query, you might specify a timeout as part of that request and say, oh, it shouldn't take longer than 10 seconds or whatever. But imagine you actually have one of your nodes is really, really slow, and it takes longer than 10 seconds. No problem, the timeouts are going to fire, and you're going to get partial results for that search request. You're also going to get information as part of the response that tells you, like, oh, a subset of the query or some of the shards were not able to actually return a result, allowing your application to do whatever you want with that information. A lot of applications, for example, they want to say, well, I'd rather return results. I would need to show like a product catalog search result. I'd rather show something rather than nothing, right? Or maybe a big fat error message if you really want. It's up to you, but this is up to you. Oh dear. The chaos shark has appeared. For those of you who have actually seen enough of my older slides, the chaos shark is a repeating character. He or she happens to appear a lot. It's sort of like a production version of the chaos monkey. I would claim that this election season, certainly the chaos shark has caused a lot of trouble. How do you actually handle chaos in your system, right? Well, there's a feature called replicas. Do we support replicas of index partitions? Answer is check. Oh, yes, we do. So as your queries are coming into the system, only the primary index partitions are going to be queried as part of your system, but there are going to be replicas. Why are the replicas? Well, if a node happens to go down or it's in trouble, what happens in Couchbase? Well, what people do is they press the failover button. So do we support failover? And the answer is check. Yes, we do support failover for FTS index partitions. The replicas, when you press the failover button, are instantly promoted to primary position, and it's as simple as that. I think that's it for my section.
Great. Thanks, Steve.
Yep.
So, enough with all these dry slides. Let's do what everyone wants to see. Let's do a live demo. So I've got running on my laptop a Couchbase Server cluster. Again, it's just a local cluster of, well, let's wait for this to come up, single node. So again, this is just a development branch running on my machine. Now the data set I wanted to look at, I wanted to use one of the samples that we ship with the application. So we're going to work with the travel sample. If you're running your own cluster, you can always load that data set by simply going to the Settings tab and then Sample Buckets and selecting Travel Sample. So everything I'm about to demonstrate is something you're going to be able to reproduce on your own with the 4.6 preview release that went out just the other day. So before we even dive in, let me just quickly show you a document from the travel sample data set, just so we have an idea of what's going on. Now this bucket does contain different types of documents. We're going to look at here as an airline document, but when we're doing this full text search, we're actually mostly going to be looking at hotel documents. But just to give you a quick sense, there's a variety of different fields in here. Some of them have text that's useful for search, but they also have this type field. In this case, it's set to airline, which is going to help us, again, demonstrate some of the features that Couchbase offers. But let's go ahead and just build our first index. I want to start by just demonstrating how easy it is, and I'll actually delete the one that I had before. We'll demonstrate just how easy it is to get started. So we're going to go ahead and press, let me shrink this down one. We're going to press the new index, new full text index button. And the only choice we really need to make on this screen is which bucket do we want to index. We're going to say travel sample. I'll give it a name. Let's just say, I don't know, travel X, just for something a little different. And we're not going to configure anything else. We're just going to press the create index button. Once we do that, behind the scenes, DCP streams are sending the documents over to the full text indexing piece. I'm just going to press refresh. We see it's in progress. That number is going up. But let's see what else Couchbase offers. I'm going to click Data Buckets, go over to the Travel Sample bucket. This is where we can see statistics for what's going on in Couchbase. But since we created that new index, so there's a new entry that's shown up here. And we know it's actually tied to that index because that has that TravelX name that we just created. So if we expand that section, some indexing stats are on the left-hand side here. So we see that the document count is now going up. That's climbing as the index is being built. We have some stats about the rate of documents being indexed. We can see how many items are remaining coming in through DCP. And also we can follow the disk size. So this is already 600 megs. So it's just sort of one observation apparent already. This index is pretty huge considering the data set, right? There's only, I believe, about 32,000 documents in this data set. And it looks like we're coming up on not quite a gig, but it's still rather large. But it's built. So let's go ahead and jump back over to the indexing tab and then the full text tab. And let's run our first search. So I'm going to search for the phrase nice view. Let's just see what we get. So we see this matched a couple different types of documents already. Again, a couple things to note. We're only seeing document IDs in the results. So that's a little bit weird. That some of the demos, other demos of full text you've seen at this conference probably showed you a little more information than that. And we'll go into why that is in a second. And let's just take a look. These are actually links to viewing the document. So we can just pull one of those up in another tab and take a look. And we see, well, right there, we see the phrase nice view appears inside, in this case, in the content field. And then again, this was a type landmark. All right? So again, it shows how easy it is to get started. We didn't really configure anything. We didn't know anything really about FTS. We just picked a bucket and pressed the create full text index. That's how we recommend all of you to get started. Now, that's only going to take you so far. So let's go ahead and look at why you might want to start customizing the mapping. So we'll go back to indexes, full text, and we're going to edit this index and make some changes. So there's a couple things you might want to do. The thing I'm going to focus on first is the size of that index, right? That was really kind of large, and we know it was indexing a lot of fields that maybe weren't that interesting. So the first thing we're going to do is add a new type. So what we've got here is this notion of a default type. Any type we haven't defined is going to be indexed the way the rules for the default type work. But we know there's a hotel subset of this, right, that has information about hotels with a lot of text fields. So let's go ahead and add a type. We're going to type in hotel. And we're going to do another thing. We're going to say only index specified fields. And the reason is we want to tell it about certain fields that are in the documents, but not, and have it not index all the additional fields. And I had another document here. Let's just quick. OK, I had a document prepared, but that's OK. What we'll do is go back to our search results and pull up a hotel. What I want to see is just show you an example of a hotel document so we can see what fields we have available in hotel documents. And I'm going to pick 3 to put in this index. So we know we have the name, in this case, Radisson Blue. So let's go ahead and configure that field, if I can find the tab I was working in. All right, so what I'm going to do is inside the hotel type I just created, I'm going to press the plus button and say insert child field. We know the name of that field is name. And I'm going to do one other change here. If you remember when we saw those search results, we were not seeing any of the actual content in the body of the results. Let's change that. And the way we do that is we say store. What that's telling FTS is to store the value of that field in the index as well. That's going to allow us to show you the snippets in the search result and also to highlight the terms. Press OK. Now, there's another field, which I believe is description. That has also useful text for searching. So let's add the description field. We're going to do that one the same way as the first one. We're also going to store that. And there's one other slightly interesting that's a little different and worth looking at. So one of the things that makes the hotels more interesting to search is there's reviews on the hotels. So these are user reviews of the hotels. And if we look at how that shows up in the JSON, there's a field called reviews, which is an array. And then inside those array elements, again, it's an object, which contains a field called content. So it's a little bit trickier mapping. Let's see how we would actually configure that in the mapping. The first thing we're going to do is something different than before. This is called insert child mapping. So previously, we used insert child field for those direct level fields. We're going to choose insert child mapping. And that's indicating to FTS that reviews section is actually like a subsection of a document, not necessarily a direct field going in the index. So that's called reviews. And I'm going to also say only index specified fields. Now, you remember at the top level, I'd said only index specified fields. I'm going to do that same setting for this subsection. And now we know there's something inside of reviews. So we're going to now say insert child field and select content. We're going to store that just like we did for the other fields. So we've done a couple things here. We've told FTS about a new type of thing called a hotel. And then we've told it about 3 different fields and one sort of subsection inside the JSON structure. There's one other thing we want to do. All the things that are not hotels would still be indexed if we didn't make this additional change. So now we're going to go down, and under this default type, I'm going to click the Edit button and uncheck the option for Enabled. So by doing that, now the additional things that are not hotels would not be indexed. So we've made a couple changes. Let's see how this works. I'm going to press the Update Index. I'm going to refresh. It's building. Let's jump over to the stats while it's building again. And you'll see it's already done. So you can already see a difference right away just by the slope of that line, just how much quicker this index built by restricting it to the hotel type and then also only focusing on those 3 fields that we gave it. Second, if you look at the size, it's now 46 megabytes, and it was over 700 megabytes the last time. So again, that's a huge improvement from an operational perspective that if we fine-tune to only search the things we're interested in, it's going to give us a much better behavior. So let's go back and see if it still works. It's another important feature. Go to indexes and full text. Let's select the TravelX index. And this time, I'm going to search for a phrase. Since we know we've got the review con in there, I'm going to search for large rat. And that's kind of a fun, interesting result. We've got my son, who was 3 at the time, tripped over a very large rat one evening by the pool after participating in a children's program. So this may be a hotel you don't want to stay at. Now, we've seen a couple things. Let's do one other thing. Let's just run that search. I'm just going to push this button a few times. And to do that, I just generated some query traffic. So if we go back, click on the travel sample, scroll down. I did that just to highlight that on the right-hand side, we'd previously seen on the left-hand side some indexing stats. On the right-hand side, we have stats related to querying. So you can see queries per second, the latency for the various queries. and again, some additional categories for errors, timeouts, and slow queries as well. So there's a lot of functionality here. Again, even with this demo, we don't have a lot of time to go into all the different examples. There's various kinds of queries you can run. Again, we just looked at 2 different simple phrase queries to sort of demonstrate how that's working. One final thing I'll show you in the demo is a feature we'll sort of get to a little bit later. There's this concept of full text aliases, right? And you can think of these as sort of symbolic links so that when someone's querying an index, there's this level of indirection between the name of the thing you're querying and the thing that's actually physically backing it behind the scenes. And I'll explain where that is, how that's used in the next section. But I just want to highlight that button to create those aliases is right there. So with that, let's jump back into the slides. For this to come back up. So the section we want to talk about now is best practices. The first rule we would like to recommend people to use is only use explicit field mappings in production. So we saw how easy it was to get started by just doing a dynamic indexing of the whole document, and that is how we recommend you get started. But we would not recommend you do that in production. Why is that? Well, these dynamic mappings are great until a developer adds a small field of text, and I say small, but it happens to contain 4K of text. And this can happen in this sort of style of development we have now with continuous integration, continuous deployment. Developer just makes a change to the document. We're schema-free, schema-less, so that's all fine. The application's all run. But all of a sudden, you just imposed a huge load on your Couchbase cluster that you weren't anticipating, right? That node that was doing the full text is now going to blow up and be spending all its time indexing this new field, which may not even be relevant to the search capability you're offering to the user. So when you get to production, you want that stable, predictable behavior. You want to be able to scale it accordingly. And then you want the confidence that that's not going to change because of some dynamic property in the system. The second is always use index aliases. This is that symbolic concept I mentioned before. Why is that? Well, the way indexes work in FTS, when you make any changes to an index, we need to rebuild the index from scratch, right? And that you don't want that downtime to face your application. So using index aliases is a way of avoiding that. So to sort of illustrate it, let's say we had a bucket called users, and we have an index corresponding to that for users. We would build a physical index behind the scenes called users v1. And then we're going to create an alias called users, which points to that. We're going to design our application to do all its querying to that query's alias. So now when you realize you need to make a change, you're going to start building users v2 behind the scenes. Meanwhile, that's indexing in the background. No problem. Your application is still querying users. But then when it's done indexing, you're going to be able to do an atomic switchover. So it's totally transparent to your application. It's still sending its queries to users. But now you're going to do this atomic switchover. Queries that are on the old one will finish. New ones will start going to the new index. And then once that switchover is complete, you can now remove the first index. This is not a best practice, but I want to recommend everyone to go watch the CNIT presentation that was given yesterday. I was in the audience for that and really enjoyed it. And I think there's some really clear takeaways for the audience here. Couchbase FTS has some really simple uses, and it has some really complex uses. And I think if you look at their example, they really found a good level of operating on the system, right? So they're building some queries manually, and that's exactly how we envisioned a lot of Couchbase users to actually be using this in production. And so I'd recommend everyone to watch that presentation and take a look at how you have to think about how your data set works, how people are going to query your data, and then manually build queries for the user, like on their behalf, right? And their presentation really gives a good example of that. So I definitely recommend check that out. I've been told their videos are going to be a very quick turnaround. So hopefully in a few days, maybe a week, you'll be able to watch that video. And finally, we want to look at the roadmap. Current status is that FTS is in developer preview. It's been in developer preview since the 4.5 release. The 4.6 developer preview of Couchbase that just went out yesterday includes a significant refresh of the FTS product. So if you played around with it before, whether your experience was good or bad, we'd recommend you to download this new 4.6 preview and give that a shot. There's a lot of time to still give us your feedback. This is planned to be a GA release in the upcoming Schoch release. Schoch is just the code name for the next major release in Couchbase. But we want you to help kick the tires. The URL here is just the standard Couchbase download. That'll take you right to the 4.6 preview that I just mentioned. And that completes our talk. So we're happy to answer any questions you have. There's a lot of stuff we didn't really have time to cover, but if anyone wants to ask questions, we're happy to field them. Sure. Thank you. Start up front.
I have a question. So first of all, we know for index we're using Lucene. So how does performance compare with Lucene and Couchbase?
Sure. So the question was, how does the performance compare to things like Lucene?
Yeah.
Right? So I would say the first thing to point out is we are doing performance benchmarks in a manner very similar to Lucene. So if you're familiar at all with Lucene, they have a nightly benchmark that they run. And there's a various suite of things, both indexing throughput, query latency and throughput on different kinds of queries. We actually have some nightly stuff that we run as well, following a very similar pattern and also using the same data set, which is the Wikipedia data set. So in terms of raw numbers, how does it compare? We've really broken it down to 3 categories. So on indexing throughput, we've closed the gap considerably, and we're in an area where we're comfortable releasing it. I'm not going to say we're faster, but we're sort of comparable in that same range. The second would be query latency. And for the types of queries that we support, and of course, we don't support nearly as many queries, types of queries as Lucene or Elasticsearch. But for the ones that we're focused on, the query latency is, again, not as fast, but in the same ballpark to the level we're comfortable, like we're closing in on the gap. The area where we still have work to do is on the query throughput. We're significantly behind Elasticsearch in the test that we're doing right now. So I would say it's something we're working on. As we get closer to GA, that's one of the criteria for us to go to GA. So we're hard at work on that. You?
Does it support linguistic slow stamping, slow form? For example, when you type in car, it will return vehicle, trucks, etc.
So the question was, do we support any sort of synonym? Would you say that's the type of transformation you're talking about? I'm just repeating the question. Is that correct?
Yes.
Yeah.
And if it supports, is there a way to configure the...
Right. So one of the things we didn't get to see in the demo, we actually have a highly configurable pipeline for building those analysis pieces, right? So the way you can think about it is there's 3 main phases we call character filters. That's for things like stripping out HTML or other characters you're not interested in. The second is the tokenization phase, where you split the large piece of text up into individual tokens. And then there's a token filtering process, where you're stemming to trim down words. Maybe you have stop word lists where you're removing things. Or in the other example you gave, you could do synonym, either expansion or compression, depending on what you're trying to do. The model we have is that this is all configurable through JSON. So we have a UI, which enables a lot of these things. But in the case of synonyms, we do not have a synonym filter today. But that's, again, something that's very easy to add because we have this sort of pipeline where we can plug in different pieces. So it would be fairly straightforward to imagine a JSON mapping which sort of includes definitions of the synonyms, definitions or sort of rules about whether you want to expand or compress the synonyms. So I would say we don't have that exact piece, but the thing we're building would fairly straightforward to support that. So that's the kind of feedback that we want to get now, right? If you come and say we're building an application and it's essential for us to have that piece now, that's the kind of feedback we'd love to get. So another thing I didn't mention, we have a section on the Couchbase forums for full text search. That's a great area where you can provide that kind of feedback to us, and we can make sure we get it addressed. I think there's another question a little further back.
Yeah, my question is that if I turn this feature on in a production system, maybe on a replicate cluster, will it be safe at this stage, or may have some impact?
So the question was, if you turn on this feature, is it safe in the data replication along those lines? And will there be any other impact to it? So I would answer the question in a couple different dimensions. The first is, it is a separate service, right? So in the current state of developer preview, again, we don't recommend you even enable the service on nodes in production. It's mainly for development and testing environments at this current phase. The second is, because it's a separate service, you can choose to run on other nodes, right? So that will give you some level of isolation that even if that was crashing or something, that would sort of insulate it from affecting other nodes in your cluster. So that's another step you could take. And then the other piece I would highlight is, again, it is developer preview. So we're not guaranteeing that any sort of like index upgrades or anything as we go forward. So you would certainly want to plan that as we go to GA, you will be rebuilding your indexes at that time anyway. So question up front here?
Yeah. Is there a plan, does it support or in future it will support key space filtering? Like for example, I'm searching for Marriott Hotel and it should return me all the documents or comments for Marriott. Only that has been posted for Marriott Hotel specifically. Now there is a document which has Hyatt in its name and the comment section, Marriott is better, it will still return that one. So I don't want that. I just want all the document with name of Marriott and comment section has some Marriott related. So
Sure. So let me repeat the question for the audience that can't hear you. It's a little bit of a long one. So the idea is, could you do sort of additional filtering on the query so that the text matching, you don't want it to be on the whole data set. You want it to only be on things that also match some other criteria. So the example that was given was the hotel data sets. You have like names of hotels or even brands of hotels, which might be Hyatt. And then you might have another comment for a Marriott hotel, but they use the word Hyatt in the description or something. And so that would match the text if you didn't restrict it, but you want to have this other criteria and force that it only match a subset. Is that a reasonable explanation? So the short answer is yes. So what we would recommend you doing in those cases is typically there'd be another field. I don't have a good example to dive into, but there'd be another field like the name or something along those lines. And what you would typically do for those is index that using what we call the keyword analyzer. So that would do basically no analysis at all. It indexes as an exact string. And then for your search clause, you would have a two-part thing. You'd say, I must satisfy this first filter, which is that the hotel name is Hyatt or something along those lines. That's an exact match. There's no fuzziness at all and nothing going on there. And then in addition to that, you also want documents that satisfy whatever the search criteria was. So it has the effect that you're searching within only the things that match that first criteria as well.
So, Marty, you guys are running ahead of time, so I'll just jump in on that. Another option you have is you can also do a must not match on an exact match, right? So in your case, you are saying filtering, I think, to get rid of results that you don't want to have any chance of showing, right? So let's say you have a field like Marty described that shows, let's say, that, the name of the customer or something. You can say it must not match that exact field. I don't want any chance that's going to happen. And you can do that behind the scenes. You can add that to the query. Not anything that the user is entering into the search box, but you can be adding that behind the scenes to the query as an additional query term, must not match. And then you don't have any chance of any of those documents showing up in your results.
Yeah, so just to summarize what Will said for the audience that's remote, there's many ways to go about solving this problem, right? So I described it by using a must clause. You can turn it around and use a must not clause as well. That'll maybe have different performance characteristics depending on the data set. The thing I would also highlight with what Will said is, and this ties to that point I made earlier about the CNIT presentation, you want to think of the queries you're building as separate from the queries the user's typing in, right? So your application is going to give a box somewhere where they type in something, right? But you want to think of a level of separation where, as Will said, you're going to augment that with additional things that you know about your data set. So you might know that in the case of CNIT, right, where they're going to be doing boosting on certain fields because they know, a match on that in this field is much more important than a match in another field, right? You don't want your end users to worry about that detail, but you know that about your data. And so there's this separation of what the user is searching for, which you can then augment with additional clauses to give the ultimate behavior that you want to show to the end user. Yep.
Another related question with the namespace is about security, like private searching. When we search a global space, right? But let's say we want to search only the private space of a login account or during a login sessions. Can we optimize it? I learned it from the discussion that we would set a must match clause, but when you do must match, you are still searching the global index.
Yeah, so the question is, could you use, is there any capability for filtering down from a security perspective? So again, in the CNIT example, it's a multi-tenant situation where they're putting data from multiple users, different accounts, customers, and so on, all into one bucket and then all into one index. So I would say they've satisfied to their satisfaction that requirement by using additional filters on the search. It's not built as a security feature, so I don't want to sell it as a security feature because it's not designed for that, but it can deliver that capability as well. But you're right, it still is searching, right? So it's not optimized for that per se. There's a couple other things you could do. Again, if you wanted to, depending on, like, let's say you had a small finite number of customers, you could try and build a separate index for each one. And that would be a better way of achieving a more physical security. But the capability to do that, we have some limited ways to sort of filter out which things go in. So we have a type field. But the type doesn't have to be a type. The type could be the name of the company. And that would, again, serve to allow you to build separate indexes for each company. We also have the key name is another way that you can filter into type. So if, for example, all documents for one customer were prefixed with the customer name, that again would be a way that you could potentially split the multi-tenant data into separate indexes. So I would say there's a couple of options on the table to get at the feature you're describing. And there's maybe some of those would work, or maybe we'd need another way. But that's, again, another good feature to bring up and discuss in the forums. OK, we have time, so let's go another question in the back.
Resource consumption versus Elasticsearch, the size of the indexes, can you comment on that?
Sure. So the question was resource consumption versus Elasticsearch. We are working on that. I would say out of the box, it's going to be a bigger index than Elasticsearch for sure. Some of those are architectural decisions. One of them being we maintain what's called a back index, which means we're almost always 2x the physical size. And that's not even if you're storing fields, right? So out of the box, that's a big problem. That's something we're working on. From the memory consumption during search, again, I would say we're better in some cases because we're not doing some of the caching that they're doing, but we're also worse in other areas. So it's a trade-off, right? I would say that's a work in progress for us. Next question.
So can you consider, with Couchbase integration with Elasticsearch, there are two options. Either I index into the Elasticsearch, and then maybe the Couchbase query works with the Elasticsearch internally, versus using the full text search. So did you guys consider that option before getting this feature, and how does it compare?
Sure. So the question was, did we consider maybe just more of a direct embedding of Elasticsearch or direct integration with Elasticsearch as opposed to building our own piece? I would say we didn't consider that because we're pretty comfortable with, if that's what you want, you can do that today. We didn't see us packaging it up or bundling it would be, from my perspective, not a very good win in any of the metrics we would look at it, right? So that would, one, we'd have to sort of somehow mesh our way that we manage nodes with their way of managing nodes if we were to try and automate that. I don't know. To me, that would just sort of muddy the water, not actually solve a customer problem. If you have the need to run Elasticsearch, you probably want all of the direct controls over managing it, right? I can only imagine the support nightmare you'd have too. Who's supporting that now when Elasticsearch would be like, we're not touching that, right? You packaged it up weird. You didn't follow our best practices. So I don't see that as a very viable option. Now, could we have chosen something like Lucene and built, again, a lot of the products in this space have done a search integration with Lucene. That was something that probably got a little bit more serious consideration. But again, ultimately, we decided we could best address what our customers were going to need with the solution we went with.
Do you guys have a calling API at SDK level, or only REST API is available?
Sure. So the question was, do we have SDK support, or is it just a REST API? So the REST API is sort of the primary piece that we've built. But all of the SDKs in Couchbase already have integrations with that REST API. So that means if you're using Python, Java, whatever, you can use the SDKs today and work with these developer previews. So the REST API is there if you want, but we would certainly encourage you to use the SDKs that we've developed. I think there was a question on this other room. Yeah. Go.
So XDCR, for cluster to cluster, how does this play into that if I have cluster A with this running and I have another data center, DR center? with this running? Is it supported by XDCR?
So the question was, how does this feature relate to XDCR? And the example given was you have a sort of a primary cluster, and maybe you have a data DR server with XDCR connecting the two. Is it supported? The short answer is it's not directly related. So the FTS is built on top of the DCP streams. So wherever you choose to run an FTS node, it's going to be getting a DCP stream from the bucket that it's been configured to work off of. So to go back to your example, if I have a cluster A in production, and maybe that has an FTS setup configured for it, those DCP streams are all local. Now maybe you also have an XDCR to this remote cluster. The question you would have is, are you maintaining a full text index on the DR setup? Maybe, maybe not, depending on what you want to do. But if you had one running there, that would be, again, local DCP streams on that cluster. So again, it would work in the sense that mutations on the production one would make their way through XDCR to the DR cluster, and then ultimately make their way to a local FTS index there if you had it.
Okay. So if I create new indexes, I need to create them on both ends?
Correct. So the XDCR does not try to transfer the indexes from one to the other, right? Those will be independent. It's just moving the data in the buckets.
Okay.
Yep, next question.
Is there any future roadmap for using your GSI index with FTS? Like, for example, get the overlap objects returned from GSI and from FTS. So
Sure.
Because I believe that range-based filtering on FTS will be tough and performance not that performant.
Sure. So the question was, is there any plans to support integrations with the GSI indexes with the FTS? In particular, sometimes you want to do filtering on ranges of things. That's something, obviously, GSI is built just for that. FTS, so I got to start by answering and saying FTS does support that. So we do numeric ranges and date ranges as well. Your point was also that maybe that's not going to be as performant as the GSI versions of the same thing. And the answer is, you're right, it probably won't be as performant. We take the approach of turning the numeric structures into terms in the index, right? So that's sort of a compromise to make the capability work. It's not the most performant way to implement range searches. So the short answer is, right now it works. You can do those range filterings inside of FTS, but it wasn't designed for that purpose. So back to your original question, what's the roadmap like? Is there some future where a single query could sort of tap into the GSI indexes and the full text index at the same time? I don't have anything concrete to share. I mean, certainly that makes sense. We could imagine sort of a global query planner optimizer thing which knows about all of the indexes that Couchbase builds and can tap into them. I mean, that sounds like a great idea, but such a thing does not exist today. And so we'd need to have more conversations about it. Certainly we're thinking along those lines. I would say a more short-term thing that gets at some of the same use cases would be nickel integration with full text. That has its own challenges. To be just honest, most of the integrations we've seen with full text and SQL are kind of rough and not very appealing. It doesn't mean we won't do them eventually, but we want to make sure what we build is actually useful to people and not just checking the box that we've integrated them, right? So that would probably be a shorter-term solution to your question without having some like global planner query thing, right? That would be sort of moving knowledge about one directly into nickel that we have today. So more thought is needed for sure. OK, we're coming up close to the end, but I think we have time for one or two more. So
languages supported? English and?
So I don't have the list in front of me. We support English, French. Again, see me afterwards. We'll pull up the list. I don't have the list in front of me. Yep. Any other questions?
Are the indexes stored in memory? And what happens if they're created in memory?
So the question was, are the indexes stored in memory? And what happens if they are stored in memory?
If they blow up, if they're bigger than?
If they're bigger than disk. So the answer is these are backed by disk. So they are in memory. They're buffered in memory while you're waiting to get things to disk, right? But they're already searchable while they're in memory. So we have a piece that my colleague Steve worked on called MOS. That has the advantage that as the mutations are coming in, they're searchable even before they get to disk. Meanwhile, we're sort of batching them up and getting them to disk as fast as we can. So that's the standard configuration that you would get if you use it. So I would say it's in memory, but only as a means to get to disk. We're then relying on disk cache and things like that for the data to be kept in, the most hot data to be kept available. The second part of your question is that we actually do support a mode in which we don't back them to disk at all. So we can have MOS never persist to disk. We can use it as an in-memory only solution. Now, if you do that, you have to sort of know your data set. You have to know how much memory is on the machine. There's a lot of like, you have to this, this, and this, and this. But for some customers, that is and is still an interesting choice, right? They maybe have machines with a lot of memory, and they just want to keep the whole thing in RAM and have it be super fast, and they understand the trade-offs that come with it. And it's time to wrap up. So thank you all for coming to this talk, and certainly feel free to see us later.